All right, so let's look at Neptune really quickly. So the discovery of Neptune. So Neptune was the first planet to be discovered only through mathematical calculations rather than astronomical observation. So astronomers found out that there's a pattern of presence of planets from the distances from the sun. So then they realized like there should be another planet just passing Uranus according to the calculations. So after they after they done the calculations, then they looked for the planet and they observed the Neptune. So in 1844 and 1846, both mathematicians John Adams and Urbain Werner predicted that there should be another planet over there, and they name it as Neptune without even seeing this planet. So in 1983, they observed Neptune from the Earth using telescope. So it looks like. All right, so the surface of Neptune is approximately the same size as Uranus, but considerably more massive. I think I pronounced it incorrectly. So the goal of this slide is to learn about the surface. So Neptune is about the same size as Uranus, as I saw for the first slide, if you remember. So it's about the 4 times the Earth diameter. Right? So like Uranus, methane in the atmosphere accounts for the blue appearance. So Neptune also blue in color because of the presence of methane. And it's 30.1 astronomical unit away from the sun. The intensity of sunlight is very low. So it is further away from the sun. So it's receiving only small amount of light. And the surface is one of the coldest in the solar system. It's negative 353 Fahrenheit. So it's colder than Uranus. It shows surface features that are somewhat like those of Jupiter, with a gray dark spot showing during the 1989 Voyager 2 flyby along the visible bands and clouds. Later in 1994, the Hubble Space Telescope did not see the spot but found a similar one in the other hemisphere. So there are ring system in the Neptune as well. Most of that, there's a great dark spot on Neptune. So if you notice the pictures of Neptune, you will see that blue dark spot. All right, so the weather on Neptune is extremely violent, probably driven by heat from its interior. Winds reach speeds of 2,100 kilometers per hour. So it's really, really fast wind flowing on Uranus, on Neptune. Also, like Uranus, Neptune is probably made mostly of frozen gas and water ice. It has been proposed that those 2 planets are better described as ice giants rather than gas giants, because they're really cold planets, right? So they are ice giants. Okay, so in this picture, you can see that great dark spot that I talked earlier. So here, these are the blue color zones, and these are belts. Like if you look at this picture closely, look at this, like there's a ring kind of thing, right? So those are belts. Those are dark blue color. These are the zones. That's little light blue color. And then this white color rings are those are not really rings, it's kind of bands on the planet. So these are high altitude clouds, right? So those are clouds. Then this is, let's say this is the South Pole. So closer to the South Pole, you should be able to see these high altitude clouds. Okay, then here, this is the dark spot. So this is great dark spot. So that's it's surprising find on a planet where it was through that temperature, we are too cold to sustain such storms, right? So there can be storms if it is really, really cold, but there is a one over here like great dark spot on Neptune. So these pictures were taken by ultraviolet images, right? So it's revealed this band-like structure. So it's very similar to Jupiter and Saturn. Okay, so sustained wind speed in Neptune's atmosphere have been clocked at over 2,000 kilometers per hour, faster than the speed of sound on Earth. So you can imagine like how fast those storms are. Okay, so we think that the Neptune's atmosphere is being warmed from blow of internal heat. So it's coming from the below, like under the planet, like in the center of the planet. The heat is transferring from the center to the surface. And maybe that is why it's creating the storms from that heat. So the extra heat drives large circular storms like the great dark spot seen on this picture. Then the orbit and rotational period. So Neptune rotates on its axis once every 16.11 hours. So the length of a day on Neptune is 16.11 hours. And the rotational axis has tilted about 30 degrees, I would say 29.58, 30 degrees from the perpendicular to its orbit, making it similar to Saturn and the Earth. Kind of, right? It takes 164.79 Earth years to go once around the sun. So the length of a year on Neptune is 165 years, let's say, roughly, round it up. So the Neptune's orbit around the sun is nearly circular. Perihelion is 29.81 astronomical unit and aphelion is 30.33 astronomical unit. So you see like these two numbers are quite similar, right? If you round it up, it's round up to 30 astronomical units. So Neptune's orbit is nearly a circle, not a high elliptical like Uranus. The magnetic field. So Neptune has a sizable magnetic field as well, which has the magnetic north and south pole tilted at 47 degrees to the rotational axis and also displays the from the center of the planet by about 0.55 of its radius, right? So here, so this is Uranus and that's a picture of Neptune. So as you see here, Uranus rotational axis and the magnetic field axis shifted a little bit, dipole shift, right? And here the magnetic axis of Neptune, and here's the rotational axis that's also shifted a little bit. The crossing is somewhere here, not at the center, right? So it's quite similar to the magnetic field of Uranus, which suggests that this odd configuration is not connected to the extreme tilt of Uranus rotational axis. So the presence of magnetic field on these planets are still a mystery to find out like how do these planets are getting the magnetic fields. And the moons and rings, so Neptune has 13 moons that are known so far, with just one Triton that is the large enough to be spherical. So this is Triton, so that's the largest moon that we know on Neptune, and it is circular in shape. So these are relatively small moons. Triton, the largest one, is about 80% of the size of our moon with about 30% of its mass, which suggests that it is made mostly of ice. Triton is in very close retrograde orbit around Neptune with a period of just 5.877 days. So as I mentioned, all the giant planets does have a ring system. So Neptune has a system of rings as well. So as you see in this picture, it does have a ring system around it. Like the rings of Jupiter and Uranus, these are made of dark rocks that are difficult to see from Earth. So that's why we feel like there's no rings, because all the pictures that we see, they are not rings are visible, but all these giant planets does have ring systems, including Uranus and Neptune. Uranus also been visited by the Voyager 2 space probe in 1989. So it's kind of, because of this was the last planet on the tour, the trajectory could be chosen to approach the planet as closely as possible without concern about where the spacecraft could go after that. So we don't know what happened to the space probe after that, but the astronomers are trying to get the best approach to the planet. So the closest approach to the Neptune was about 3,000 miles from the north pole of the planet on August 25th, 1989. Then the Voyager 2 obtained some particular good images of Neptune's ring system. So the pictures that you saw earlier are taken from this space probe Voyager 2. The next visits to Neptune at its moon, Triton, is Neptune orbiter and Triton lander, tentatively maybe in 2030. So if you are interested, you can be a part of that project. Okay, these are the pictures that taken from space probe Voyager 2. So it's the ring system is really clear in this picture. And if you go more in detail, you can see those moons and clearly the rings, right? All right, so please answer the question on top hat.